Hello and welcome to the Adelaide Podcast, the podcast for the Adelaide.net user group. I'm your host, David Gardner. This is a recording from our June 2024 meeting, OpenTelemetry, adding observability to any microservices environment, with Glenn Versweyveld. And now over to the presentation.
Maybe first up, who am I? My name is Glenn Versweyveld. I'm from Belgium. So that's a long way from where you are. You can also find me on Twitter. I don't call it X either yet. It's Depeshi. And if you want, you can also hit me up on Mastodon. It's up to you what you prefer. But let's continue with the talk. All right. Before I can go through the demos, we first have to go through a few slides of theory, explaining a little bit of the namings and the naming conventions and what observability is and what it's all about. So in general, we have several signals, like we call it in observability, and three of them are really big, that we see them as a sort of must-have in your environment. First up is monitoring. And monitoring consists of capturing metrics about everything that you have up and running. That could be hardware, could be software, anything that you like. And why do we do this? Because we want to gain insights. We want to know the performance and the health, and everything is going as we want it to be going. And secondly, we can add logging if you want to. That's where you can record certain actions or certain events that you think are necessary for later investigation or for auditing or anything for that. It can also help with detecting anomalies if needed. So that's also a big part. And the last part that we are going to discuss is tracing. And the main focus will actually be a little bit on the tracing part, because it will capture and show you what are the actual flows of things happening in your software environment. Because we want to reconstruct the flow of events in your distributed system. So a pro tip, if you want to start with observability, at least try to look at tracing. The other ones are not mandatory, but of course you get a better result if you do all of them. But at least try to get a hold of tracing in your ecosystem. So if we think about tracing, well, what do we actually want to do? Well, we want to have a distributed trace available. And a distributed trace, what is this? Well, this is a method to observe requests as they go through your landscape, through your ecosystem. And a request can be anything. It can be a user doing an action on a website, but can also be a batch process running on a server that's triggering things on your APIs or services or whatnot. It can also be that a build pipeline is being triggered, that you want to monitor that. So it's a broad concept, but at least you want to see what happened during the period that request started and ended. And why do we want to do this? Well, because we want to have this right-hand side picture, probably, and it could be that you are currently at the left-hand side environment, that you have a lot of interacting services in your domain or in your company, and they're doing all kinds of actions, but you probably don't have a real clue if something happens. Where did it start? What were the previous items? In which flow the user was running, etc. So the end goal, and I hope at the end of this talk and the demo, we can get the right-hand side picture. The end goal is that no matter where you are in the request, you can at least trace back to the beginning and know what happened. Because that's what the real benefit of an end-to-end trace, distributed trace is. Well, and how can we handle this and how can we do this? How we can make this happen is the thing to do is not that difficult. You need to identify when the first action happens in your software environment or hardware environment. And as soon as that first action arrives, you need to tag it with a unique identifier. And as soon as you have that done, then when the request goes through to another service or to another endpoint or no matter what inside of your landscape, then you have to provide that identifier along. You always have to pass it along the stream. And then as another service picks up that request, it can also see that there was already an identifier and then hook up to that end-to-end trace and also pass it along if it needs to call other services. And we, as software developers, already understood this benefit. And during the years, there were already a lot of standalone solutions to handle this. Big companies create this themselves. They set a specific HTTP header, X-correlation ID or something like that, and fill in a unique identifier. So people already had solutions for this problem. But of course, we saw that if you need to talk to other technology stacks, or maybe you work with an external team that doesn't have the same standard, then we get into problems. So the real benefit for everyone was if we can create a standard way of doing this. And there, OpenTelemetry comes into the picture. There is an open source standardization today. It's called OpenTelemetry, where you can use the tooling they provide to leverage all these technologies and all these things to do in your software environment. So OpenTelemetry will take care of everything that needs to be done to create those identifiers and hook them up if needed. So what is it? Well, it's a set of APIs and SDKs and also a few tools that are available. And it's actually designed to do more. But in essence, it will generate all needed data that you configure that it needs to generate. So you can tell it to generate the trace, extra trace information and pass it along, generate metrics information and pass it along, and even annotate logs if needed. And if you go to the GitHub repo, it's in the link in the slides, the OpenTelemetry.io, then you can see that there are already APIs and SDK available for the huge list of technology stacks that we as developers use. Because a lot of companies saw that this has a benefit if we use the same way of working. So a lot of big companies are actually providing the SDKs for the OpenTelemetry repository. So even Microsoft is helping out on making this .NET SDK better. But maybe we have to talk about what is it not. That's also important so that there are no mistakes. OpenTelemetry is not a data store. So it will, if you want to gather the data, the metrics, logs, and traces, you still need to provide your own data stores. And you need to have a certain area where you want to store that information so you can do an analysis and look at that data later on. That is not what the OpenTelemetry does. OpenTelemetry only guides you and helps you on creating the metadata on top of the metrics, traces, and logs, right? But it's not a data store. So it's also not a visualization tool. It's just something that is running in the background and that adds extra information and does extra things if needed. And also, it's not an analytics or a management environment, all right? So you still, as a developer or a company, have to choose what you want as data store for later investigation or work. If you then look a little bit deeper at the terminology, what OpenTelemetry is all about, then we, like I already talked in the beginning, then we have one big component and it's called a trace. So as soon as an action arrives in your environment and you are using OpenTelemetry, OpenTelemetry will investigate that action or request and will see if there is already an annotation with a trace ID. If it's not there yet, it will generate a trace ID and will add that to that request as an annotation. And then each time a certain element in your environment needs to do work on that request, then we talk about a span. So that's a small work unit within that trace is a span. After this slide, we have a visual representation and it will become more clear. So what OpenTelemetry also does is, as soon as a request comes in, it will see if it's already has a trace identifier. If not, it will generate it and put it on the request. And also it will create a root span, so the first work unit. If we took it as an API or a service, and that API talks to another service, the request goes through, the identifiers are also passed, so the trace identifier and the span identifiers. The other service, OpenTelemetry, will do the same investigation, will again look at the headers and see if there's already a trace ID. If there's already a trace ID, it will generate only a new child span, so a secondary span, and will attach that to the queue of all the spans that are already available in the metadata. And by creating that queue, at the end, you will have an end-to-end trace, and that trace consists of about one or more child spans. So if you now take a visual representation of what this means, well, for instance, if you have a website and a user clicks on a button to do a certain action, and that action calls one of your APIs, and you are using OpenTelemetry, that API will see, okay, this request, does it already have a trace ID? If not, it will generate it, and it will also generate the root ID, the root span ID. If that API needs to call a separate API, the same process happens, and a secondary span ID will be attached. If that second API maybe calls a database or a distributed messaging system, the same thing can happen again, over and over. And at a certain point when the request is done, you will have this nice overview of a complete end-to-end trace. So the end goal of the talk and the demo will be that we have this same representation that I now have in the PowerPoint visible for us in a certain environment that we can investigate. I already mentioned this. The OpenTelemetry repository, GitHub repository, consists of about a lot of sub-repositories, and they're oriented by tech stack. So you can just go to the GitHub repo and see if for the technology that you are using, there's already a tech stack available. For .NET, there is one, and it's a very good one. Certain technology stacks are still work in progress, but most of them are already usable if needed. And it are these SDKs that you need to add to your software to get the instrumentation going. And the instrumentation is actually the thing that I talked about, that it will do the investigation of the traces and add the necessary metadata if needed. If you then look at the OpenTelemetry infrastructure, OpenTelemetry has also something they provide for a standardization, and it's called the OpenTelemetry protocol. So they also define a certain protocol on how they see if you need to pass trace information from one endpoint to another endpoint, or log information or metrics, then they define a certain protocol. It's called the OpenTelemetry protocol that defines all the needed attributes and values that you as a SDK provider need to add to be adherent to this protocol. So the most of those technology stacks SDKs are OpenTelemetry protocol ready, so you can just use that, and then your trace information will go over the wire in an OpenTelemetry protocol format. If you then want to send that information to your data stores, because I already told you OpenTelemetry is not a data store, so you still need to have some place where you can store the information. then you have two options. Or you store that information directly from your actual code, software code, so that the code pushes the data to a certain store. If you do this in an OpenTelemetry protocol format, then you have to investigate first if your third-party store is able to collect OpenTelemetry protocol data. Okay, so that's something you need to do and need to investigate. If that is not possible, maybe you are using a store that doesn't understand OpenTelemetry protocol out of the box yet, then there's a possible workaround. Then you can use the OpenTelemetry collector. So that's one of the tools that's also in the OpenTelemetry repositories that you can use. If you then dive a little bit deeper into the OpenTelemetry collector, well, the OpenTelemetry collector is something that you run alongside of your software, and it consists about three components. You have certain receivers, you have certain processors, and you have exporters. And how you need to see this is that you create pipelines in the OpenTelemetry collector, and that pipeline will link a receiver to an exporter. And you can define in that receiver what protocol you want to use. It can either be OpenTelemetry protocol, but it can also be a proprietary third-party protocol. The same thing goes for the exporters. You can define an exporter telling you where the data needs to go to your data store. And you can also tell it to either send it in OpenTelemetry protocol format or in a third-party format. So if you now take a visual look at this, this means that if you are currently already maybe using Jaeger in your environment for certain trace information or anything else, or Prometheus for metrics, and those two maybe don't understand OpenTelemetry out of the box, and you want to send OpenTelemetry data from your software, from your APIs or services, then you can put an OpenTelemetry collector inside of your environment, define an OpenTelemetry protocol receiver, so the data goes from your software environment to that receiver, goes through a processor, and then goes to Jaeger or Prometheus, but in the Prometheus data format or in the Jaeger data format. So the OpenTelemetry collector can do on-the-fly data transformation if needed. This means that you have a huge benefit that you can already start with OpenTelemetry if you want to, even if you have third-party backends in your ecosystem, because the OpenTelemetry can do data transformation if needed. The processors in the middle, why are they useful? There are certain processors they indicate here, the batch processor. That means if you have a lot of data coming in and you don't want to overload your back-end stores, data stores, you can just add the batch processor to the OpenTelemetry collector, and then the collector will first batch data in certain thresholds before it sends it in one go to the backends. So that can be a nice thing to have, but there are all other processors also available. So you can do certain filtering that you say, okay, certain data that comes in, I'm not interested in that data actually to be stored in my data store. So you can filter that out in the OpenTelemetry collector. So the collector has more meaning and is often used in environments than rather sending OpenTelemetry data from your services straight through to the backends. So the OpenTelemetry collector can help. You can also do data annotation with attributes. So if that means that that the OpenTelemetry collector gets data from a certain service, and you want to be sure that you get that extra information, you can add attributes if needed to the data stream and pass it along to the external data stores. Now, the OpenTelemetry collector can be installed in various ways. There are two main things. You can install it as a separate runner, as a real agent. Just install it as a service on a machine, or you can install it as a certain gateway through Docker instances. Maybe, like we'll be doing a demo just as one Docker instance, but you can also, of course, do it on an Azure Container Apps environment or on a Kubernetes environment if you want to. But the demo will show the gateway setup. And then, of course, the big thing that we need to select is our data stores. For the demo, I went for the Grafana tooling. If people are not familiar with that, during the demo, you will see it. So the Grafana tooling has three major data elements that we can use. We have Prometheus, and Prometheus can gather all metric data. Then we have Loki, and Loki will be used to store all logs that we generate. And Tempo is the data store where we store all trace information. And then we have Grafana on top of this to do querying on the data sources and also to generate dashboards if you want to have nice representations on all the data that comes through from OpenTelemetry. But like I already told you, and I showed you in the OpenTelemetry collector, you're not limited to using Grafana. You can just pick and choose what you want. So if you want to, and you are familiar with Elastic tooling, with the Elk stack, you can even choose that if you want to. So for each component that we have in Grafana, you have a counterpart in the Elk stack. So you have an APM server for the traces, a Logstash for the logs, and a beats to gather metrics. And everything is then visible, not in Grafana, of course, but in Kibana. That's the dashboarding called for the Elk stack. So you can even choose that. And Microsoft is actually also picking up. You can also push to Azure Monitor services that you can just use App Insights for the same things. So look in App Insights for the logs, traces, and metrics if you want to. So like I told you, it's up to you as an organization to choose the backends. And if the backend doesn't provide you an OpenTelemetry protocol-enabled endpoint from the box, then just put in an OpenTelemetry collector, and probably there is an exporter already available for the backend that you want to use. For the bigger ones, at least they are. And then we come to the demo part. We'll be using ASP.NET Web APIs. Just generate two services to introduce you that surfaces can talk to each other, and we can see this visually. And then we have a Docker Compose environment where we spin up all our data stores, where we can store our data to do some analysis. And to also show you the power of OpenTelemetry in distributed system, I also added a RabbitMQ messaging queue, so that even if you post messages on a message queue from a service, and there is a message worker that later picks up that message and does some interaction, even that is visible in your end-to-end tracing. So that's also a very nice thing to have with OpenTelemetry. This is the overall setup of the demo. I don't have a website. We're just going to use Swagger for this. But there are two small APIs. There's a weather API and a location API. If you do a certain thing on the weather API, it will call the location API, and the location API will put a message on the RabbitMQ message queue, and there will be a .NET message worker picking up that message from the message queue and just do some processing. And the goal is that we get Prometheus up and running to do the monitoring of the endpoints of the weather and the location API. And we use Grafana Tempo for the tracing and Loki for the logs. All right, with that, because this is the last slide, I will show that in the end. Let's go through the demo. Is this big enough for everyone? Just thumbs up in the room, maybe. I can see the room. All right, thank you very much. So what do we need to set up? Well, we have the two APIs here. We have a weather API and a location API. Nothing fancy, just a new .NET Web API and then one controller with nothing doing all too much. So let me spin up a new instance. I will go through the code in a bit. Okay, so this is the weather API. We already have that then. Then we spin up the location API. There we go. Okay, we have that. And then the last thing we need to do is start up the worker. That's true. I get an exception because I didn't start RabbitMQ yet, and the worker tries to hook up to RabbitMQ. So we first have to set up the environment of all the data stores and RabbitMQ. And this is done through Docker Compose. Why did I pick Grafana? Because Grafana gives you all the Docker images, so you can do everything locally. You don't have to have any cloud environment available. You can also already start and test things locally completely. And that's why I picked Grafana, because that's a nice thing to have. So the Docker Compose file that I provide in my GitHub repo contains all the data stores already. I'll briefly go over this because it's actually not that very important. You just have to pick a data store, of course. So we have a Prometheus image that we are running because we want to store the metrics. We have a Tempo instance running also from Grafana to store the traces. We have a Loki instance for the logs. And then on top of this, we have Grafana, so we can actually visualize all the data stores. What's extra available inside of this Docker Compose is, of course, the OpenTelemetry collector, because the collector will receive the data from our services and will push it to the data stores. And as last part, we have the RabbitMQ, where we can actually store messages on the queue. Now, if we run this, I'll just copy paste this. And you can see it will be starting those Docker containers. And I'll briefly show you also in my Docker environment that they are up and running. Somehow it seems I needed to pull in new images on this machine. It would have been better I did this up front, but yes, still have to wait a little bit. Maybe I can already show you first what is an important part of your setup is, of course, if you want to use the OpenTelemetry collector, showing you this in the slides is very easy. Let me show you how you actually do the configuration. So if you want to start with an OpenTelemetry collector, you have to create a YAML file where you define your pipelines. Like I already told you, a pipeline is just defining a receiver where the data can come in and defining an exporter where the data can go out to your data stores. So one pipeline needs a receiver and an exporter, okay? So the first thing that you need to do is you have a tag for all the receivers that you want to configure. In my setup, I only configured one receiver, and the receiver will always be in the OpenTelemetry protocol. So this means that all the data that I push to this OpenTelemetry collector has to be in the OpenTelemetry protocol format, okay? But you can add more receivers, like I already showed you in the slides. You can also add third-party data proprietary types if you want to. And then for the exporters, I defined 3 exporter types. One in the Prometheus data format, that we can push data in Prometheus data format to Prometheus. Also an exporter in the OTLP data format, and one in the Loki data format, because at the time of configuration, Loki was not yet able to receive data in OpenTelemetry protocol format. So we have receivers configured, we have exporters configured. Now we have to configure our pipelines, and that's what you do in the service area. There you will tell for each OpenTelemetry signal that you want, which pipeline configuration that you want to use. So here we tell it, hey, OpenTelemetry collector, if you receive metric data, it will be in OpenTelemetry format, and you need to push it in a Prometheus format to Prometheus. For traces, we tell OpenTelemetry protocol, hey, OpenTelemetry, you will receive trace information in the OpenTelemetry protocol, and you export the trace information again in the OpenTelemetry protocol. Then you have to go to the exporters again if you want to know the details. So in our case, it means that we will send OpenTelemetry trace information in the OpenTelemetry protocol format to our Tempo data store. And Tempo does understand OpenTelemetry protocol format data. That's why we have here the OpenTelemetry protocol to OpenTelemetry protocol configuration. And then for log information, we tell it to receive data also again in the OpenTelemetry protocol, but export it to Loki in a Loki data format. So that's an important part. This configuration needs to be set up, otherwise your OpenTelemetry collector will not do anything, of course. With that said, I think the Docker containers will be ready already. I'm not sure in which window it was, but let's look at our container. Oh, seems we have a problem. Yeah, here we are. Thanks. Yes. So I like to use Portainer because it gives a very nice visual representation of all the Docker containers that are running in your environment. You can also use Docker Desktop, of course, if you are familiar with it. And then you can see that these are all the containers that I started. So we have our backends, we have Loki, Prometheus, Tempo, and we have the visual representation on top of it, Grafana. And then you can see the ports that are being used. So from Portainer, I can now easily open my Grafana environment and use it locally without the need of having a cloud environment available. So normally, if everything is going correctly, we should already have data available in our environment. I don't know. I didn't do any Swagger actions yet, I think, or maybe I did. Let me just see. So for the people not familiar with Grafana, there is an Explore tab, and that Explore tab enables you to write queries on top of the data stores. And like I already told you, we configured 3 data stores. We configured Loki, Prometheus, and Tempo. So if you want to see at all the logs that are being generated by services, you select the Loki data store, and then you can use the query language that is available, or you do it in code. You type the Grafana query language, or you use the visual builder to actually quickly see what's available. So in our case, we have those drop downs that we can use to actually work with our services if needed. So let's see if we can now trigger an action. Yes, I get some data. Let me execute this a few times, and let's see if we actually get some data now. We don't get data. I think I already know I need to start the other Docker environment. Excuse me. So let's do that. Okay. I needed to do this one. Okay, I think we're up and running again. Let's see. Yes, here we are. So if I now go to the weather API, okay, this is up and running. Open Grafana again. Take a look Yes, and now we have our data. So the first thing that we added actually to our environment, I didn't talk about this a little, not too, only briefly during the slides, but the first thing that we added was health point checking, endpoint checking. So that's the monitoring part. So I've added health endpoints to the two APIs. I will go through the code at the end. And we have a health checker, a probe. It's called black box in the Grafana setup, and it will ping those endpoints, those health endpoints, to see if the APIs are up and running. And that means that now in our Grafana environment, you can have dashboarding available for your teams. So if a certain team is responsible for a certain set of microservices, then you can create these dashboards showing them, oh, all your microservices are all still up and running, what the latency is. You can put alerts on this. Maybe if you are in a production environment, you can even get information on when the SSL certificates will expire. And every data source that is available in Grafana, you can put alerting on this and post those alerts to maybe your Slack, Teams environment, or use SMS as alerts or anything about that. So also in my demo setup, we have the monitoring part covered, and it's covered with the metrics information that is being stored in Prometheus. Then second to that, we have those other elements available. So Loki for the logs, and now we have data. So as soon as logs are being generated and pushed into Loki, we can now use this query language to look at them. So we can say, okay, give me all the logs for a certain job, and a job is one of those data elements in the OpenTelemetry protocol, and it indicates which service that is generating those logs. So if I'm only interested in all the logs that the weather API generated, I can just run that query, and then I will get all the log information as JSON, because the thing that the OpenTelemetry protocol uses to push those data elements with the setup that I did is in JSON. And then you get all the data attributes and values visually represented here in your Loki environment within Grafana. And the thing that you maybe will notice already are the things that I talked about during the slides. If you use OpenTelemetry, OpenTelemetry will annotate your log files and will add those trace IDs and span IDs. And I already told you, if you want to have an end-to-end trace, you will need to have the trace ID available in all your ecosystem, and each service endpoint, each worker endpoint will have a certain trace span ID, and that will also be generated and visible here. And with that, if we now have Loki information available and it's annotated with trace and span IDs, I can now open the representing end-to-end trace visualization in Tempo by just clicking on it. And then you can see, here the visual representation. It's a little bit small, excuse me for that. Like we had in our slides, in our demo, that if you do a certain action on one endpoint and that endpoint calls another endpoint, that we have that visual representation in our end-to-end trace. So we can see that the weather API is actually calling the location API. But let me do a more advanced demo and also try to incorporate the RabbitMQ. For that, I will just stop the health point probing, otherwise our logs will be spammed with that. Okay, so I stop the black box container because that's the one doing those health endpoint checks. All right, we go to Swagger, we have our weather forecast, we try it out. As soon as I put some latitude, longitude information in this, it doesn't matter which, it's just if there are, then it will actually call the RabbitMQ worker message queue. But of course, I first need to start that worker again because I stopped it. So let me see the architecture. Yes, where is worker? Okay, stop that run, and now it should. Why doesn't it run start? None of the provided endpoints are reachable. RabbitMQ is actually started on the endpoints. Oh, the service worker is started already in the side of the Docker container. Oh, excuse me. It's already running. I thought it wasn't running, but it is. Okay, that's good. Let's execute some actions again. There we go. Then we can go back to Loki and then select a job again. Let's refresh the set. Okay, run the query. It's only the health endpoint still. There's something fishy going on. I'm only getting the health endpoint information and not getting the data information. Let's go back to the beginning, see if we made some mistake, but I don't think so. All the information, the weather. So health is running. The weather forecast is running. And Swagger is running. Okay, let's try it again. No. No service name location provided. It is running. And let me maybe restart the Docker containers just to see if something happened there. And if this doesn't work, sorry for the demo failure, but then you have to try it yourself at your machine. But normally it should work, that all the data is available in the environments. Okay, I restarted the Docker containers. Final try. Yep, let's stop the black box container. And let's go to Grafana. Explore. We need to generate data, so let's do that again. The weather one, Swagger, weather forecast, try it out. Yes, now I'm getting a response. Okay, good. Let's look at Loki again. Select a job, select the weather API, run the query. Yes, now we have the data. I think something happened with starting up the containers. Not sure why. So we now have the actual get weather forecast call that I did in Swagger. And if I now look at tempo, now we have a more interesting graphic. Then we will now see that the weather API actually did an internal call to the location API. The location API did a RabbitMQ publish of a message, and the RabbitMQ worker later on in the time frame took up that message from the message queue and also did some processing. And now everything is correlated to the same end-to-end trace. And why is this important? Visually, this doesn't look that spectacular, but why is this important? This means that now no matter which team, so for instance, a separate team is responsible for the RabbitMQ worker. If they gather, they have an exception in their logs, they just open their logs. So this is only the log line, one log line of the RabbitMQ worker, and they go to the tracing and they will have the same visual representation. So they can now work backwards to see which actual call the user did on the website that generated the error message in their log lines. And that's the power of having OpenTelemetry in all your small environment parts in your ecosystem, that you can now correlate certain log lines, exceptions, or it doesn't matter what, or see it visually on the trace representation where that request came from and what happened before the generation of the data. So visually, this is everything from the demo side. Now let's go to the code a small bit. So how do you actually add this? If you are in .NET and you want to use OpenTelemetry, you actually only need to add a certain set of NuGet packages. So if we look at our weather API, let's open that one as a good representation. So if you look at the configuration file, then you will see that you can add a set of NuGet packages, actually OpenTelemetry, OpenTelemetry Exporter, OpenTelemetry Extensions, and OpenTelemetry Instrumentation. And if you have those available, then everything will be done for you. Then you only need to do a small kind of configuration in your .NET environment, and everything will be instrumented for you. So the instrumentation, ASP.NET Core, HTTP, and runtime are the things that Microsoft helps maintain. And then it will inject all the ASP.NET Core information in the correct OpenTelemetry formatted tags that we can see in those log lines and those end-to-end trace informations, so that we get all the data needed. You don't have to do this. These NuGet packages do that for you. But of course, you need to do a small setup, a small configuration, and that's what you do at the start of your program. And it's in this small part. Let's try to make it a little bit bigger. So maybe go through. If you have a web API, if you are familiar with that setup, then you have a builder available for you, a web application builder. And then at the end, when you want to start it, you do an app run, and you do a build and app run. So in the beginning, you do some configuration for that builder, and you have to add certain extra elements if you want to have the OpenTelemetry data generated. First, you have to tell it to use OpenTelemetry. You get this extension method because you added the OpenTelemetry NuGet package, and you just have to wire up the configuration. You have to tell it which instrumentation you want to use. So in my example, I tell it to use the .NET Core ASP.NET Core instrumentation and the HTTP instrumentation, and you have to tell it which exporter type to use, because we also added the exporter NuGet package. We tell it to use the OpenTelemetry protocol exporter. So all the data will be exported from your services in the OpenTelemetry protocol, and you just have to point to a certain endpoint. And in our case, in the demo that I did, all the data goes to the OpenTelemetry collector. So the only thing that you need to do is tell it where the collector is up and running. And that is something that you do in your app.config. appsettings.json, and you just have to point to the endpoint where it's up and running. So in my Docker environment, the OpenTelemetry collector has port 4317. So in all the services that you want to use OpenTelemetry, you have to use this endpoint to push all the data to the OpenTelemetry collector. So if we go to the service worker, that's a backend console. It's a console app, but it's one of the type background service. The same setup. You just add the needed NuGet packages that you want to use. And at the startup, you also do the same configuration, telling it where to store that information, the OpenTelemetry information tool. I briefly skipped it, but this is for the tracing. You add it. If you want to have metrics pushed, you also add the metrics. And you want to have logs, you can also add the logs. In my setup, I did a little bit special thing, because what I see in most current environments, a lot of people are actually already using Serilog. Serilog is a log API that you can use to do a lot of formatting and attribute setting and stuff like that. So in this setup, we also use Serilog. And if you want to use OpenTelemetry, also for Serilog, there is an option to push OpenTelemetry protocol data. But then the configuration needs to be at the Serilog configuration and not at the general builder configuration. So depending on the examples that you see online, the logging information will either be in the general settings, or if you use another logging framework, it will be in the logging framework's settings. So in my case, it's at the Serilog configuration that I push all the data to the OpenTelemetry collector in this case. And also for that, for Serilog, you have to add a certain configuration in the app settings.json, but that's a different talk. If you want to know more about Serilog, maybe you can ask another talk presenter to tell you about this. And with that, I think we are finished with the demo. So let me do a small recap. What did we actually do? So we introduced several software elements, in our case, 2 web APIs and 1 service worker, distributed messaging service worker. We configured them all to use the OpenTelemetry SDK to generate OpenTelemetry metadata on top of our logs, metrics, and traces. We push all that data to 1 OpenTelemetry collector that is running in our Docker Compose environment, Docker environment. And the OpenTelemetry collector we configured to capture all that data and push it to the correct data stores, the logs to Loki, the traces to Tempo, and all the metrics to Prometheus. And then we used Grafana on top of it. For the Prometheus, we had the dashboard so that we can see all the monitoring of our services, that they were up and running. And we used the Grafana query language to go drill down into the log lines and then use the Tempo representation to have a visual representation of our end-to-end traces. And with that, I can maybe bring up again the last slide. If you want to use this same demo, it's already available on my GitHub repo. It's this middle link. I will email the slides to the Meetup admins so they can distribute it, or I'll post it as a chat on the Meetup. I will see. And if you want to have a more broader overview and also get into alerting and everything, I also have a Pluralsight course on the complete topic, and that's available at the link beneath, where you can get a more in-depth explanation of everything that we covered in this little talk. And with that, I thank you for attending. And if there are any questions, feel free to just ask them or put them in the chat if needed. Yeah, go ahead. I'm not hearing anyone, so I think the mic needs to be, yeah.
Can you hear me now?
I hear you now. Great.
Fantastic. I do have a question. I don't know if there's even an answer to this one, but is there a way of securing those OpenTelemetry endpoints where the telemetry is ultimately delivered so that some ne'er-do-well can't inject inappropriate material into your telemetry?
Yeah, a very good question. There are several options for that. I didn't talk this during the demos, but we use the OpenTelemetry collector in our environment. Let me double check in the configuration. So in my Docker Compose file, we added the OpenTelemetry collector. Yeah, so let me share my screen again, then I can explain it a little bit. So the image that I actually used is not the basic OpenTelemetry collector image, but it's the OpenTelemetry contrib image. So there is a separate extended version of the OpenTelemetry collector, and it's called the OpenTelemetry contribution repo. I put a link in top of the config in the YAML file, so you can take a look at it. And there, community members can add extra functionality to the base OpenTelemetry collector. And one of those added contributions is authorization headers on top of the setup for OpenTelemetry, so that you can use a basic authentication header key if you want to, or use an OAuth flow to secure your endpoints. Yeah, so it's not available in the base setup, but it is available through one of those collaborated added items. Yeah, and that's why I added this one, so everybody can take a look and then see what's added extra on top of it. Yeah.
Another question?
One more.
So is all this just for network requests, or can some service or something add their own checkpoints to it? So say it has to do some long-running thing, and can that trace that long-running thing versus the rest of the request?
So what I did in this setup is actually the easy basic setup, because you saw that I only do a configuration at the startup of our APIs. But the SDK can also do manual instrumentation if you want to. So you can just also, if you want, in code, generate new traces or new spans and add extra information or things like that. So if you store your trace ID somewhere or anything, and you can pick it up again, then you can do extra things with that if needed. The setup that I did is just a basic instrumentation out of the box, and then it will look at all the requests as is. But if you want to annotate it again, or if you say, I have a separate long-running instance and I want to segregate that from the trace that is already being done, then you can do that in code and just spin up a new trace, and it will generate a new trace ID. And in your logs, you will see that long-running task is then separately from the other trace that is available. So it's up to you if you want to do that. But if you want to do that, then you have to write code. Then you cannot use this kind of setup that you only do the configuration. Then you have to actually extend your actual code base. And then you have to be the owner of the code base, of course, to be able to do that. Yeah.
What's the current state of managed services support? So say using Azure Monitor instead of Grafana.
Yeah. So
what's the support
also
like
for that? Yeah, for that is also some different options that you can go to. There is an exporter available in the OpenTelemetry collector catalog that you can push to Azure Monitor. You can use that one if you want to, but Microsoft is also seeing that a lot of customers now go to the OpenTelemetry route. So just a few weeks back, they provided a managed service for OpenTelemetry collector, but that OpenTelemetry collector can only be used currently if you are in an Azure Container Apps environment. So I'm still sharing my screen, am I? Yes, I think so. Huh? I did a complete blog post about that setup if you want to take a look at that already. Let me see, where is my... Oh, that's not the one. I think I killed... I don't think so. Let me open it again. Is this? So I go through the complete setup. Also for this setup, the starting demo is also available at the same GitHub repo. So I'm using .NET Aspire. So that's a new .NET frame tooling that you can use to create distributed cloud environment services. And with Aspire, we get OpenTelemetry also out of the box. It generates all the needed data. And Aspire is one neat feature. You can just use the Azure developer CLI to push it to Azure Container Apps. And if you use that, it will also enable you to add that managed OpenTelemetry agent, and that's actually an OpenTelemetry collector running inside of your Azure Container Apps environment, and then it will do everything for you. It will collect the data. The only thing that you need to do is then configure where the data needs to go. And in my setup, in my setup. So the extra configuration that you need to do for that managed service is tell it where it needs to push your data to, the data store. And there you can also tell it to push to App Insights. And then you get the same thing going, that everything that is running in your Azure Container Apps environment will generate OpenTelemetry data, and all that data will come to in your Azure Monitor environment. So the logs will be available, the traces will be available. I think I had screenshots at the bottom of the blog post. Let me see. Yeah, you can get information in Azure Monitor, then what service called what other service, and you can get all the endpoint logs that are being called and with the status on the timings, and you also get that end-to-end tracing available in Azure. But like I said, to get this in Azure Monitor, there are two possibilities: or you use Azure Container Apps with a managed service, or you use an OpenTelemetry collector and use the Azure Monitor exporter to push it to Azure Monitor.
Awesome, thanks.
Just know that the managed service is currently still in preview. That's the only thing I need to say.
That's usually how it goes with new Azure services.
Yeah, indeed. Yes, indeed.